So yeah, I did my PhD in particle physics, and I got really lucky. I got to work at CERN, like during the time where they discovered like the Higgs boson. I got to like see that firsthand. That trash bag is not like a rigid object, so it constantly, it's easy to like slip and miss. So we thought to ourselves, if we can solve this task, then we kind of know we have an unlock here. That's a great question, and to be honest, this question keeps me up at night. So we actually explored this a lot in a recent release of Gemini Robotics 2. Like, we really focused on unlocking the humanoid form. And I think it was mostly, maybe for a couple of reasons, by putting like a wrist camera next to your contact points, and then that maybe gets you out of the hole. But I think ultimately we will have to face this like tactile thing and in robotics, and dexterity will get really good up until a point, and then I think it will break down because you don't have tactile information.
Gemini Robotics has got legs, and literally so. Google DeepMind has been doing frontier robotics for years, and its latest release takes things to another level. Robots can walk, balance, and use their hands with real dexterity, all driven by a single AI model. So here to talk about that is Kanishka Rao. He is a director on the robotics team at Google DeepMind, leading the efforts to bring AI out of the lab and into the real robots. Kanishka, thanks for joining.
Thanks so much for having me.
So to start with, before we get into the news, I have to ask this. So there's a lot going on in the AI space lately, in last 3 years, and it feels like we are living in a surreal time. And you've got a front row seat. Not just developing, but observing all this. Does it feel a little bit crazy at times to you?
Yes, I think I never kind of get used to that feeling that this is kind of normal. So I completely agree with you. Yeah, it's been a crazy journey in the past few years, not only in robotics, but just, as you were saying, just generally how AI is developing every year. And this year just alone, we've seen all these like kind of these agentic workflows with like these like harnesses, and so it's really cool to see how quickly AI as a whole, like the whole community is like just improving in terms of capabilities, and then also how this like translates to the robotic space. So I'm obsessed with like the physical AGI part of it. So just seeing how all these breakthroughs, those same kind of like lessons, they all seem to like transfer to robotics. So in the end, like our goal is to essentially just like, ride the same wave of these AI breakthroughs, but in the robotic space, and kind of leverage all those like, breakthroughs to make robots more useful. So yeah, it feels like uncomfortably exciting, like how quickly things are progressing.
And people get used to it so soon. Even like, I'm sure you do get used to it. Like robots were dancing 2 years ago and now nobody cares. Must be happening a lot, and like, okay, if you take a step back, it does look amazing in the hindsight.
Yeah, I tried really hard, maybe it comes naturally. I genuinely, whenever I walk into the lab, like this is small feeling of just like, this is so cool. And then kind of, the mundane day-to-day stuff takes over, but I try to like really take a second every day to like appreciate how far we've come. I've been working on robotics in this team, I think close to like 8 years now. And I just like think back to like year 8, year 7, year 6, and it's just incredible the pace of improvements. And then you start thinking in the future, like, year 8 years from now. So yeah, it's easy to get kind of used to it, but robotics, like, again, like you see the robots moving every day, so it's in your face more maybe, but yeah, it's just really incredible to see the improvements.
Yeah. So can you tell us a bit about your journey? You've done PhD in physics and astronomy, which is quite different from what you're doing right now. So how did the inspiration come for going into software and robotics, and how did you end up here?
So yeah, my journey was kind of all over the place, not really, well, actually up until a point, I think I really wanted to do like physics. Like growing up, that was like my one passion. I really wanted to like learn, how the universe works and, some of those questions. So yeah, I did my PhD in particle physics, and I got really lucky. I got to work at CERN, like during the time where they discovered like the Higgs boson. I got to like see that firsthand. So got incredibly lucky there. And I got to like see how these like big organizations work. And if you have a huge ambitious goal, how can people from all over the world come to like solve that problem? So that was really like the scale of that, organization CERN was like really impressive, and the rigor at which they do science. And really, yeah, I was kind of like pursuing physics. And one of my graduate school friends was also interviewing at Google, and he was like, Google is is hiring physics PhDs, and I was very curious, like, why would Google want a physics PhD? So I decided to interview at Google, and it was like a software engineering interview. So I had to like study like what a binary tree was. I had no idea, and so I somehow passed those interviews, and I got an offer, and I had like my postdoc in physics in one hand, and like this weird software engineering role from Google. And I decided at that point, hey, I'll just try Google for a year just to get a sense of what that world is like. And then I'll come back and do my postdoc after that. And I think that was like 13 years ago, and I'm still here.
Wow.
So I think it's been really satisfying doing research at Google and DeepMind, because it feels like you're still at the cutting edge and you're still exploring. And I get some of those same itches that I got from physics kind of met here. And so, yeah, I worked on speech recognition for 5 years. And it was, again, like I got very lucky in my career. I got to see, when I first joined speech, it was very much like a research field. And the speech recognition error rates were too high for it to be usable. But I think like the day I joined, or the week I joined, like these deep neural networks and these like specifically RNNs became like very popular. And all of a sudden the speech errors, they started like plummeting, and they very quickly, I think the year after I joined, we had these things called the LSTMs that were very, very good. And all of a sudden speech went from this like research field to like, hey, this technology is now usable and useful. And I got to see it like become a product. And then one day we had like 100 million users using it every day. So it was really cool to see how research breakthroughs can impact and benefit people, and it becomes like a product that's used all over the world. So seeing that like really kind of like fueled me to like, what is the next big unsolved thing? And that's what brought me to robotics, I think maybe like 8 years ago. And I'm still kind of waiting and looking for that moment where, hey, robotics is now useful enough, solved enough that this is going to go outside, into the real world and start impacting and benefiting people at scale. So that's, yeah, currently how I got to robotics.
Do you wonder if the two of the fields will collide at some point, where all the research in particle physics may provide some research avenue in robotics?
Yeah, so I hope so. I think even like Demis, I think, talks about this a lot. Like one of the kind of aspirational or maybe ultimate goals for AGI is to enhance or solve science, and to like basically increase the human knowledge of our universe. So yeah, I'm hopeful that some of these like AGI based scientists can come up with these new theories. There's so many fundamental questions in physics, like that are still out there, things like dark matter or quantum gravity or unsolved problems. So I'm hoping that some of these AIs, when they're advanced enough, can do this. And then also the physical AGI part is like, all of these experiments in physics, they require massive, detectors to be built. It's like physical work, and there's like inspecting the detectors when there's a lot of radiation in there where humans can't go. So there, I'm hoping that robots can help, maybe build these detectors or maintain them. So yeah, I think both the digital and the physical AIs will help, like advance physics knowledge at some point, and that will be really incredible to see.
Yeah. Let's get into the new stuff from Google DeepMind. That is
Sure.
Gemini Robotics 2, which is the shiny new release in the robotics policy and control space. And the new thing that caught my eye is that it can now control the whole body of a humanoid robot. It can walk, it can crouch, and it uses the same model, the Gemini Robotics 2 model. So why does it matter that the same model can control the walking part of the humanoid? Because usually you see is that part is trained by sim to real, and then fused into a VLA using that controller.
So I think even in our release, like there's still a controller that is in charge of like balancing. What we have here is like the vision language action model is kind of providing like targets for that walking. And basically, I think this is important because we're combining whole body control with the manipulation part of it. So if you just have like a dancing robot, for example, then you just have your controller that dances. But if you want to go now pick up something from the floor, you have to be very particular about where you step and how far you are from that object when you start crouching, and then how you extend your arm. So we're really focused on the manipulation and interaction part of this whole body control, which you cannot really separate the legs from the hands there, because how you step and how you move your hips, all that matters for you to then pick up that object from the back of the shelf, when you're crouching. So it's really critical that all these joints kind of are controlled by a single model, as a human would think about how they move.
I see. So the VLA is kind of agnostic about which kind of robot it is.
Well, to some extent, it still knows, like, for example, how many joints are in there, because it gives like actions that are suitable for that robot. So I think it knows like some of the embodiment prompts for as you would say, but it's not built for like a specific embodiment. So it's built for like any embodiment, but it still has some embodiment specific knowledge to control those specific joints.
I see. And the really impressive demo that was the robot with 5-finger hands tying drawstrings of a trash bag, and that was done with the Apollo robot from Aptronics, right? So what kind of unlocked this dexterous manipulation? Was it like specifically planned into the architecture, or did this emerge as a capability?
So yeah, I think we've been kind of pursuing dexterity for a while, and we've really been limited by like the hardware, right? So initially, I think in previous releases we talked about like a single parallel rod gripper that has only essentially 1 degree of freedom. And then I think we've also used in previous times hands that have had 5 fingers, but you cannot control them as with that many degrees of freedom. So with this release, we are controlling these like Sharpa hands, and each hand has 22 degrees of freedom. So it's starting to look more close to like how a human, all the flexibility and range of motion that you have. So it's not just like grasping, but it's also like, you can have these like these, and you can control each one of these fingers. So I think the breakthrough here was being able, a single model to be able to control all these degrees of freedom together with your vision to that task. And I think that trash bag task, it's kind of like, it was like the most difficult task that we could pick so that we can solve the research for that task. And it's kind of like, our show off task, because it's very, very difficult, because it has to do very precise moves. It has to do with very flimsy materials like the plastic. The trash bag is not like a rigid object. So it constantly, it's easy to like slip and miss. So we thought to ourselves, if we can solve this task, then we kind of know we have an unlock here, as opposed to like a much easier task. So we had to push on the boundaries of what the hardware is capable of. And that led to like the modeling breakthroughs of how do we get the model to then control all these degrees of freedom to come together to do this task. And the nice thing is that once you unlock this recipe for hands, then you can do a lot more tasks with it. So even though we develop it with a few tasks in mind, the methods themselves are general. So we can use them for now to solve many, many more tasks that kind of go beyond like, simple hardware to do much more like human-like tasks.
Right. And for that kind of dexterous manipulation with 5-finger hands, do you use teleoperation data, or is there a way to scale just human egocentric data to train this kind of behaviors?
Yeah, so I think the kind of recipe to do this is not fully solved yet, and we iterate with this like every single release. But what I can say is like it is a mix of kind of all of the data sources. Like I think us and a bunch of other people also talk about this like data pyramid in robotics. So we have like, teleoperation data, we have simulation data, we kind of have humans egocentric data. So I think all of these have a role to play, and what mix they have and which one is useful for which kind of intelligence is still a recipe we're iterating on, and it's not, I think, fully solved. But I think we're close. I think we'll know, which ways, because not only about like which data is useful, it's also which one is scalable, and these all scale in different ways. So really to solve like any manipulation task in the world, you want lots and lots of data. So we really think about the scaling laws of each one of these and then kind of trade off between those.
Right. And some robot, like even though there are 5-finger robotic hands, all the hands are different in subtle ways. So if you are training teleop on one robot, does it really transfer to other robot types? And AI learn from all of them together?
Yeah, so I think we're seeing signs of this, and they're very encouraging. And I think that's one of the benefit of how we're approaching robotics is we don't develop a brain for like a single embodiment. So we really have we try to have a nice representative set of robots in our model. So we've introduced like more complicated humanoid robots, but we still have gripper-based platforms and more fixed tabletop things. And in our previous release, Gemini Robotics 1.5, we talked about this like motion transfer techniques where data collected on this one robot, we could see signs of life of that on the other robot. So I think we still continue to see some of this in our portfolio, where since we have such a diverse portfolio of robots, the model learns to kind of think about tasks in a embodiment agnostic way, because it's seen so many different forms. So it learns like picking up an apple with a hand looks like this, with a gripper looks like this, with a head looks like that. So just by the scaling laws, you want to have a lot of diversity in the physical form. That encourages the model to abstract away and just learn the essence of what a task is. So yeah, we're seeing some of these signs of life that we can then generalize to like new embodiments. So even in our release, we took our models trained on some of our more data-heavy platforms, and then we kind of fine-tuned them on robots we had very little data on. And very quickly, the model is able to like adapt within like, I think, hours of new data. It can then connect the dots between like, oh, I've seen all this other data with all these different embodiments. The only thing different here is like the embodiment. I can quickly like figure out somehow that I need to change these many things to get me to like be performant with this embodiment. So we're seeing some very encouraging signs that this is a good strategy to train a foundational model for robotics, is you want to have a nice representative set of embodiments so that your model can deal with an unseen embodiment.
You mentioned motion transfer. Is there a separate module which is kind of retargeting all the motions, or is it a learned algorithm?
I can't talk about the specifics, but it's essentially like a learn thing. Like again, our philosophy is definitely like data and learning and scale is what will solve everything. So yeah, we definitely don't do anything that's like engineered or specific in that way. So we definitely bet on like scale and deep learning will solve the day.
Mm-hmm. Another key piece of the ecosystem is the embodied reasoning model. So that one understands the instructions, plans, reasons around the scene. So why is that a separate model and not part of the larger model that does everything in the single pass?
That's a great question. And to be honest, personally, I've gone kind of back and forth between these two. Like again, like talking about this bet on scaling, like another kind of bet is like, oh no, it should be a single model, end-to-end trained. It will just do everything in the end. But I think we're seeing like there's some very powerful intermediate steps. Like even you take today, for example, the coding agents that we're all used to, and we use so much. Even there, like we're seeing like this notion of a harness being so powerful. Like a good harness can make a mediocre model look good and a good model really excel. So I think the similar kind of reasons make this ER model very attractive, where in our latest release, we are kind of using it as a little bit of a harness where it's able to communicate with the user and it's able to orchestrate the VLAs, and it's able to then understand the progress of the VLA and decide when to switch tasks. So this combination of like a separate ER model that's really good at one thing, and then this VLA that's really good at another thing, this combination I think is working really well. And again, like as I said earlier in the interview, like we're really trying to see how the digital AI space is playing out and learn lessons from them. So again, this explosion of like autonomous agents with like these harnesses inspired us to create this kind of like agent now. So ER model is like more of an agentic model that can basically use robots as physical agents to do some of these much more collaborative and long horizon tasks. So I think at least for the next few years, it seems very reasonable that you'll have some of these like, 2 or 3 model systems that really excel at doing some of these elaborate tasks.
Right. And in the digital AI space, distillation seems to be working pretty powerfully. Do you think that those techniques can be applied in robotics with multiple models? So
I think it's hard to predict that, because I think physical distillation will be quite different, because you have to, I guess if I'm understanding your question correctly, it would require like kind of unrolling the model on a physical robot and kind of get the trajectories that way.
Or in simulation.
Yeah, or in simulation. I think if you can access enough of the state space there, you may be able to like unroll the models enough to get that. I think a lot of the the boundaries between good models and bad models are like failure cases. So your simulation will have to be pretty good at like getting those counterfactuals of like, hey, if I'm picking up a cup, if I hit it, if I knock it over, it should spill. So I think those boundary conditions are going to be very critical to like capture. But yeah, potentially some of these distillation techniques might also work for physical models.
You introduced a safety benchmark. I haven't seen many safety benchmarks in the robotics industry. So what inspired getting this safety benchmark out? And in terms of having safe, like choosing between safety and performance, where do you draw the line? Because if the system's being too safe or too conservative, you miss out on doing some capable tasks.
Yeah, so that's a good question. I think robotics is very, very competitive right now, but I feel like, or we've kind of agreed it in our team at least, like safety should not be one of those things. I think safety should be more collaborative across like, robotics labs. So we're trying to like basically put out more and share more there. So this benchmark is one step towards that, where we want to explicitly show how we're measuring our own safety. So the ASIMOV benchmark is a great one where we've talked about, it's kind of again like the ER, in the reasoning safety. And in this update, we've made it, again, since we've made it more agentic, we have more agentic kind of safety use cases. So we really hope that this will showcase not only all the challenges associated with robotic safety, but also kind of have a clear benchmark where people can compare their various safety systems on. So we really are more open about our safety benchmarks and how we track progression there. And then, yeah, your question about capability and safety, that's a great one too. There, I think we really have to make sure that the intelligence that powers safety has to be on par with the intelligence that powers capabilities. Because if one of them is off, you're going to get a mismatch. Like if the safety is too powerful, then it will just stop doing any actions. If it's too weak, then it'll be too dangerous. So we're kind of build both the safety system over the same things that kind of the reasoning and the action systems are built off. So the same kind of Gemini models. And so at least there's like a intelligence match between them. And then, yeah, I think we really have to be careful about like, I think maybe in these early stages, it's okay to be overprotective and overly careful about some of these as we're still understanding their capabilities. So I think we have like a pretty extensive, agentic safety layer now that controls the entire stack. But really, robotic safety is like going to be the most important thing to solve. I feel like people are very focused on capabilities right now, but if you want to deploy these to like homes and factories and logistic spaces, safety will be like the biggest thing to solve. And you'll have to think about all the way from the agentic orchestration layer all the way down to controls and physical, this collision layer of the safety problem.
Mm-hmm. Switching to a little bit of longer term trends in the industry. So Jim Fan at NVIDIA, he recently declared there is a end of VLA paradigm, and him and others are betting on the world action models instead, right? And there are different camps, like in companies like Generalist and Sunday. They are training the models from scratch using the UMI data. And there are other approaches as well. So do you find any of those other approaches that are not VLAs interesting? And do you expect the industry to converge on certain recipe, because underneath all is this transformers algorithm?
Yeah, so I think great question. I think robotics, even today, like even though we made so much progress and we've talked about these like step changes, I still feel it's again, we're going back to that speech moment where it felt solved. Robotics is not solved today. So there's still, I believe, some fundamental breakthroughs needed to get to that place where it starts feeling like it's ready to be, deployed and be useful and benefit people. So I think these questions of like what kind of model is like the backbone intelligence of actions. Is it a VLM? Is it a world model? Or even like the data question of like, hey, is it like this like, human data collect versus teleoperation? So we're actively exploring all of these. And, this is not, we've been working on these for like years. So we definitely have been exploring some of these questions. But I think it's just unsolved yet. So it's hard to like claim what's going to work. But I do think that these trends do. So there's like, a trend where kind of like there's breakthroughs made and everybody kind of exploits it. And then you get to the end of exploitation and there's like more exploration. So you'll go through these cycles. And I think, yeah, some of these ideas will work out and then people will start converging on them and they'll find the limitations of that. And then we'll kind of like have another explore. So I do feel like the next few years, some of these ideas will be kind of would either make it or break it. And then I think maybe 2 or 3 years of these like cycles, and then we're like close to like getting to the final answer of, okay, roughly robotics, is solved with this general recipe.
And most of the data sets we see is vision based with some robot joint action data, but we don't see much of sensory data for hands. So is that gonna change the way people think about these architectures?
That's a great question, and to be honest, this question keeps me up at night. So I really care about how dexterous robots can get and how they use their hands. And you've pointed out a big kind of almost flaw in current robot models is like essentially all the state of the art models today are vision based. Like Gemini Robotics 2, and you can have like proprioceptive input, but there's no, as you said, like tactile information. But if you think about all the manipulation that us humans do day to day, it's mostly tactile based, right? You're not really looking very carefully. When you're tying a trash bag, you're not looking at every single way your finger is moving. You're kind of just like going by feel or memory. So there's this mismatch between how we think humans solve all these dexterous tasks day to day and how robots are solving them. So I think there's a couple of reasons for that. One is, again, this bet on using frontier models to solve robotics. Well, all these frontier models are trained on the internet of data, and those have tons and tons of visuals, images. So you have a very, very strong prior of like what the world looks like. And you have almost no data set in terms of tactile information to touch that even compares. So one way this could play out is that vision is just going to be king because frontier models are built off vision, and you can leverage that by putting like a wrist camera next to your contact points, and then that maybe gets you out of the hole. But I think ultimately we will have to face this like tactile thing and in robotics, and dexterity will get really good up until a point, and then I think it will break down because you don't have tactile information. Another reason why we really haven't been able to do this research well is because skin is like a really difficult hardware problem. Like to replicate all the richness that comes out of your skin sensors, especially on your palms, it's so rich and diverse. It's going to be a while before we figure out how to do that and replicate that. So I think there will come a time when skin will get solved, hopefully, and we'll be able to include tactile data into our frontier models. But until then, I think like vision will take us a long way, and it'll be interesting to see, how far does it actually go.
How far do you think we are from physical AGI, if we can even define what physical AGI is? And what do you think are the key limiting factors to getting there?
So I think actually physical AGI is very easy to define, unlike I think digital AGI. So physical AGI, at least to me, is I have a robot in front of me, and let's say it's a humanoid, and I ask it to do anything that I could do, and it should be able to do it. And that's basically it. I don't think it requires superhuman capabilities like a specialist human would do. Like an average human adult, whatever they can do, the robot can do it in the same time. I think that time is also critical. You can't take an hour to do something it takes me 5 seconds to do. So I think that's the definition of physical AGI for me. And I think we're kind of far from there. So I think, some of the big breakthroughs are still around, I think I would say like kind of general, just your usual bets in robotics, like kind of like generalization, mastery, dexterity, kind of understanding. I think humans are very good at, you throw them in any new scene and they'll be able to do the task. So I think all the breakthroughs that we're making, they're still not human level. So I think once we start measuring against humans and getting to that bar, then we'll start hitting physical AGI. So the definition for me is very human centric, and that's the bar. So I think, we're still not there, as we talked about, with like how dexterous humans can get and how high our success rates are to doing things and how quickly we can do them. So I think still, again, as I said, a few breakthroughs are needed for us to get to that point.
Does it matter how fast the AI is able to learn? Because humans take, like, if someone's new at a job, they take anywhere between 5 days, 10 days to get the physical tasks going. So does it really matter? AI does it in months or days?
No, yeah, I think that's a great point. I think a physical AGI definition must include that you can learn a new task as quickly as humans can. So either some kind of in-context learning or something quickly on the job that you can quickly absorb and replicate. Yeah, it's a great point.
You said, I was wondering if we have all the pieces of the puzzle to solve the physical AGI, or is there a fundamental breakthrough needed in either in computing or algorithm, and all those converge into enabling the physical AGI?
That's a great question. It's hard to say. I would say, I think especially on the continual learning, as you just pointed out, I think there's still algorithmic breakthroughs needed. Maybe these algorithms already exist today, and probably all the ideas that need to be solved for robotics are out there today. So it's not so much like generating new ideas; it's to understand like which ideas make sense here and executing them really well and showing that this will scale. So I don't think there's like some fundamental computing breakthrough needed. Again, like the level of intelligence that we've seen from the digital AGIs, or not AGIs, the AIs today, it seems like robotics is not like a much more sophisticated, at least in computation, intelligence needed to solve these physical tasks. So I think it's just a matter of like probably the data bottlenecks and kind of understanding some of these algorithmic differences and kind of like unlocking those. But again, like as much as the kind of digital AI progresses, like again, we've hitched our wagon to that. So those step changes also kind of take robotics with them. So maybe just like it's just a matter of like waiting until those models get so good that robotics kind of gets like solved for free on top of them.
Mm-hmm. Google DeepMind also has some amazing world model, generative world models. Has the robotics team been using some of those for either evaluation or synthetic data generation?
I think, we even published some work showing that we can use them for evaluation. I think the really attractive part about some of those models is like they seem to understand motion quite well. So, like if I don't know, have a prompt that says, pour, coffee into like a mug, they do quite well. I think at I/O, like Demis talked about how there seems to be some like physics understanding in these models. And that's very attractive from a robotics perspective, because if you can build a perfect, physics simulator of the world, then you basically solve robotics, but then you can learn that understanding from that. So I think, going back to your point of language models versus motion models, I think both have their trade-offs. With language, like VLAs, we were able to really build instruction following robots that you can really talk to and understand, their thought process, for example. And then some of these motion models are very attractive because they might be able to tell us how, or understand motions better and generalize better in the motions. So we're looking into some of these properties, and it's very exciting to see where this kind of research will lead us.
And are the word models going to become good at fine things like dexterity and understanding those movements?
I mean, again, it's hard to predict some of these, but I think again, it's like a matter of like what's in the data and what's in your benchmarks.
Maybe robotics can help improve those aspects in the world model, and it becomes a feedback loop.
Yeah.
I wanted to ask about something that a lot of developers in robotics are wondering. On the frontier digital AI side, there is a popular opinion among tech leaders that the model layer will become commoditized. We are seeing that in the programming AI, like a little bit right now. And so, do you think the infrastructure part and the application part in robotics will be more, more sustainable economics wise compared to the model, or is it like a whole systems problem?
Yeah. So again, that's a very good question. Again, it's hard to again predict that, but I feel like with physical AI, there is a pretty large overhead for deployment, right? So you do need to make sure that your robot, has again the correct harness, the correct infrastructure to hook up the model, and then there's still today, even though we do talk a lot about how well cross embodiment works, there's still work to be done to like fine tune, for example, for a particular embodiment and figure out the quirks of that. So I'm not sure, which layer will be a commodity. So I can't really speak to that,
Right.
but definitely the AI part seems like right now the bottleneck in terms of like capabilities.
And how does Google DeepMind think about humanoids? Is it just another form factor that we need to solve? Or should we treat that as kind of a preferred general purpose form and something that other robots can also benefit from?
Yeah, so we actually explored this a lot in a recent release of Gemini Robotics 2. Like we really focused on unlocking the humanoid form, and I think it was mostly, I think maybe for a couple of reasons. One is it really advanced the research because there are some research assumptions you might make on a grouper-based simple tabletop robot, like we've done in previous releases, that may not hold for like a much more complicated robot. So focusing on the humanoid form with the whole body intelligence and the high degrees of freedom hands really pushed us to revisit some of those assumptions and make sure that our intelligence still works for the humanoid. So it was a great and remains to be a great embodiment to really push the state of the art of a frontier model. And again, like I personally believe, again, like physical AGI would be that whatever I can do, the robot should be able to do. Then again, that leads us down a path of like something that looks like me has my kind of form to be able to replicate that. So I think that is critical. The second one was, I think, we definitely want to make sure that we don't just build, again, models for humanoids. It should be a general purpose robot, that a model that works for all robots. So again, that forces us to think about, we cannot take shortcuts for the humanoid or hard code anything that's humanoid specific. So it really, again, forced us to make sure all our modeling methods were agnostic to the form. So I think it's good for pushing research, and it's good because our world is built for humans, and we want to make sure we can do all the tasks that humans can do. But on the other side, we also want to make sure that our models are completely humanoid agnostic, because there's other trap where even the humanoid robots will keep changing, right? Whatever form we're training on today, 5 years from now, it will be different, right? Different joints, different configuration. So we really don't want to anchor any single embodiment and really have the AI be kind of embodiment proof. So generally, keeping that portfolio of embodiments kind of keeps us honest to that endeavor as well.
Right. To close it off, I wanted to know, is there a specific task at your home that you would like a robot to do?
So many. I think that's one of my biggest motivations for working on robotics is I really dread doing a lot of home chores. And if a robot can do that in my home, then I'll be very happy. I think, a lot of the tasks that we all kind of dread, do the dishes, do my laundry, take out the trash, clean the house, like anything I could think of. So yeah, I think all of those would be great if a robot can do those for us in the future.
Yeah, that would be awesome.
Yeah.
That was it from me. Did you have anything that we might have missed?
No, yeah. Thanks, Devang. It was like a pleasure talking to you. Thank you for having me on.
Yeah, thank you so much. It was a pleasure.
Thanks. Bye.